Particle data sampling works kind of in a similar way. I'm going to create a very simple scene. As you'll notice, probably almost everything today is created from scratch because I want to show you how to operate the Magma without actually knowing much even about Maya. You can just go and create the very basic objects, use the Krakatoa objects to create particles. Let's say we create a volume. And what I'm going to do here is I'll switch it to jitter mode, and I'm going to enter 3 for the render spacing, and I'll disable the viewport spacing, so both viewport and rendering are using the same size. This is a random distribution, very loose, like not too many particles. This will be my reference particle system, which I'll be sampling. I'll create another PRT volume from the same box. I'll switch it also to jitter, and I guess I can live with the current count. I can change it later if I need more particles. And on this one, on the second one, I'll create a Magma. And I'm going to output to this color channel, for example, as usual, in order to visualize what I'm doing. I'm going to try to do, I'll press Alt-O for the depot, and then I see that the nearest particle is P, so I create the nearest particle, and then I drag from here and says, yeah, you need an input particle, so let's create that one and add the first particle system that we created as the input. And the second one is the lookup point, which should be in world space, so I get position. All the position channels that we're using in Krakatoa Magma are in object space of the object. If you remove the object, the positions won't really change unless you convert them explicitly to be in world space. And the output of nearest particle is also world space. So right now, for each particle, we are finding the closest particle and setting the color based on the color of that, actually to the position of that particle. And that's kind of not very usable, or not very useful in this case. What I want to do is I'll subtract from this position. This is a world space position, and this is a world space position. I'll subtract the one from the other. And now I get something funny. That looks like a cellular map almost, where the vector connecting each particle with the closest particle gets turned into a color. And I can use this to actually create something that looks like a cellular map. I'm going to take from this subtraction, which is a new vector, one vector minus the other. I'll draw a out VM, which is vector magnitude. And the magnitude, of course, is a float and it doesn't work as a color, but I'm going to draw an out FB, which blends two inputs. I'll press Control W and Shift Control W to swap the first and second and third inputs. And now I have a black point where the reference particle is, and it goes into white within 1 unit distance. So we have to normalize it, and we can, of course, go and say we'll divide this one by the average distance that we have between the particles in the first system, or I can use here a property query. So if I change my base particle system, this would automatically adapt. Right now, I won't waste the time. I'll just assume that 3 is the number that we'll be using, and I can subtract. Potentially, right now, I have I should probably actually put the divide in the magnitude before that. So I'll press Shift and Backspace, select the 2 nodes, and add that one there. The result will be the same, but what I can do now is I want to subtract from 1. So this is a float. And if I create a node here and switch this one to be a float, the default float input is 1. Do I have it? And update this one, yes. And now we have white where the particle is, and as we go away at distance of 3 units, we are getting black. And of course here I can connect, for example, if I press Shift 1, Shift and the keys on the top row create colors. So Shift 1 creates red and Shift 6 creates yellow. And now we have yellow glowing in the middle, going into red around, and I can of course adjust those. So I'll click as color and select the exact color that I want to have. But we actually created something that creates like a cellular map just by sampling the nearest particle from one particle system to another. Currently, the nearest particle doesn't operate on the current system, so I cannot sample how many neighbors I have around each one of those particles. It's on the wish list, but right now you need a copy of that system in order to sample itself. But with two systems, it works well, and most of the time, that's what you want to do anyway. All right, there are some other operators that do particle sampling. There is, in addition to the nearest particle, there is a particle sum radius, and the particle sum radius uses similar inputs. And in fact, I'm going to disable the reordering for now, switch to manual, so I can move this guy here closer. But I don't even have to connect to those nodes. I can go and drag, and when I release, it says there is already an existing input particle. Do I want to use it? Or create a new one? I'll use the existing one because I need the same system. And in fact, I need the same input for the world. So the menu already contains the existing nodes in the scene and gets me there. And I have currently a radius set to 0.1 and a fall off of 1. I'll set this radius to more, something like 2. And I'm going to expose the color channel, for example, of the first particle system as an output. My first particle system currently doesn't really have any color, so I'll go and create another magma and create a random color. Won't be exactly random, it will be actually noise-based. So I'll say a function v creates a vector noise, and then I need the position. That means that currently this value will have positive and negative values on the colors, and I can potentially shift that one up if I wanted to, but for now I'll keep it there and just see if I can sample those colors. So now I have this color output, and I can go and directly connect this color output to my color output of the other node. I start seeing some glows around here. I think I'll go to the other magma and boost a little bit this output, just multiplied by 2 or 3 or something. And if I update this one, those colors become a little bit more obvious. So I can change the radius. In fact, I can connect another node to control it, but I can just change the default and say go in a radius of 3, and now I can go even in a radius of 5 or something, and it's just sampling the colors around, and it's adding them together. That means it's actually additive currently, and it kind of looks glowy and really neat. But if I wanted the average color and not the sum of all the colors around, I can go and divide this color output by the total weight, and this is meant to do the averaging. If I do this, this is now the average color. So you have a relatively few operators that can do relatively complicated things depending on the math that you're performing with them. And you can take a low resolution particle system and then create a high resolution particle system and steal data from the one into the other by just asking around what particles around, what colors they have, or what velocities they have, what normals, and so on.